And chapter 5 deals with population ecology, where we start to look at what makes populations grow or shrink the way they do. And so to start as basic as we can start, let's just say, what are kind of the main numbers you want to know about a population to decide whether it's growing or not? Like what would you need to know about a population is one species in one area. What are the numbers you want to decide, hey, that population's growing, or hey, that population's probably staying about the same, or that population's shrinking? What do you want to know? We want to know the number we started at. Absolutely. What else? Cook it down to the most basic stuff. What causes a population to grow? What causes a population to shrink?
Available food.
Okay. What else? Okay. Okay.
Like disturbances and natural disasters.
Good. Cook that down to something even more basic. When you say predators, when you say disturbances or natural disasters, what do those things do? What do they do?
How they kill the population.
They kill stuff. So cook it down, and what we want to know is the what rate? Death rate. You want to know the death rate. That's thing 1. What's thing 2? Yeah, because you said food, you said whether there's available mates, all that is going to affect the birth rate. So birth rate and death rate, let's start with that. Most things that you said boil down to that. But it's not quite everything. For example, if I consider the population of humans in Springboro, what's that population doing? Is it growing or shrinking? You know? Yeah. When I started here, there were 900 kids at the high school. Now there's over 2,000. That would be a growing population, right? Is it because the birth rate went up? No, human birth rate stayed pretty constant. Is it because the death rate went down? No. What was it? Which kind? What are people doing? They're moving to Springboro, right? People move here. They move here. That's called immigration. And that can affect a natural population. That happens. Individuals can move into a population of any type. What's the other one? What's the opposite? An E instead of an I, right? Emigration. And we can take those 4 and basically set up an expression that'll tell us in a very simple way, is the population growing or not? Basically, if births plus immigration is greater than deaths plus emigration, we got ourselves a growing population. So we are going to start with the simplest kind of population there is on Earth and run some numbers. So you're going to need a blank sheet of paper. What's the simplest population on Earth? What's the simplest organism on Earth? Huh?
Dog.
A dog? Is that what you said? No. Dogs are super complicated.
They don't act like it.
Well, okay.
Like so much one cell organism?
Which one?
Amoeba?
No, amoebas are more complicated than the ones I'm thinking of. Bacteria, remember? Prokaryotes? They're simpler than everything else because they don't have a nucleus. They don't have all those membrane-bound organelles. Yeah. So a bacterium, let's talk about them. Let's talk about how a bacterium, if you give them everything they need, your average bacterium reproduces about every 20 minutes. You don't have to write this in your notes. This is for the, you don't have to write it at all. You're just gonna, I'm gonna tell you that, and I'm gonna ask you if that's the case. Now we start with one bacterium. How many are we gonna have after 2 hours? That's the question. I'm gonna give you 3 or 4 minutes to figure it out. Okay? Go. Yeah, on your paper. Okay, a couple things. First of all, if you're thinking that you just add one new bacterium every 20 minutes, what's wrong with that?
You're not accounting for bacteria that are being made, making more bacteria.
Each bacteria that gets made also reproduces every 20 minutes. So what are we really doing every 20 minutes to the population?
Double.
Population is doubling every 20 minutes. That makes it a pretty easy math problem, right? You probably do it in your head. The other thing is that some of you are very strongly visual people and are starting to draw little circles for your bacteria, which works fine. But I'm going to tell you that you probably want to switch to numbers at this point because it's about to get kind of crazy. And the final thing to know is that remember that it's times 0. It's times 0 that we had one bacterium. And so by time 20 minutes in, we have 2. Probably the easiest way to do it by hand is just to write the times down and then just start doubling. So what is our final number? Who's got it? 64. Good. So 1, 2, 4, 8, 16, 32, 64. No problem. Even if you were drawing the circles, you might have gotten that. Yes, Ben?
You have just done 2 and 6
So why? Why does that work?
because 120 is 120 minutes
Mhm.
in 2 hours, and it's 20-minute increments. By 120 by 20, you get 6. Then if you start with sort of number 6, and so you'll just do 2 to 6 because it's doubling every time. Every time you.
What's that called?
I forget what it's called. Exponential growth.
Okay, exponential growth. So a few of you have had the math and it's stuck well enough that you remember exactly how this works, that there is a way to shorten this using exponents. That's great. We're going to keep doing it this way for now. And then I will show you a trick where you don't even have to know how to use the exponents. And that you can do this in a way that I promise, I don't want to oversell this, but I'm going to change your life today. I swear. I'm going to allow you to save yourself. Like for me, I would say I can measure the time that this has saved me in weeks of my life. All right, okay. So, but really, right now, I just want you to figure out after 6 hours. 6 hours, how many bacteria are we going to have? Go. At a certain point, you haven't used a calculator yet, you're probably going to start feeling it toward the end. The numbers get a little big, at least for me to do in my head. If you're into computers, you're recognizing computer memory numbers, right? Or that one game. Yeah. Yep. Yep. So, from 64, we go to 128, 256, 512, 1024, 2048, 4,096, 8192. 8192, 16,384. 32, 7, okay, help. 68, 65, 536. 121.
131.
131, thank you. 072, and finally 262,144. Grew over 250,000 bacteria, and it's been 6 hours. Yeah. Now, you can do it this way. You can do it the way you guys figured out with an exponent. You just have to know how many doubling periods there are. If 20 minutes is the doubling time, and you got 6 hours, how many doubling periods is that? Turns out it's 18 of them. So if you do 2 to the 18th, you also get this answer. What that doesn't give you, though, is that doesn't let you easily graph this. You can graph it by hand with this data here, but I'm going to show you a better way. Grab a device and open up a new Google Sheet, please. You need a new Google Sheet. And you're going to name that Google Sheet because you're going to need to keep track of it for the next however many days this unit takes. You're going to name it with your last name and then population graphs. Remote folks, you have a blank sheet in there for you already attached to where this video is, so please use that.
So it's just the last name, population graph.
Yep, your last name and then population graphs. And then you're going to learn 2 tricks. Your top 2 cells, top left 2 cells should say time in minutes and number of bacteria. And then you're going to type in 0 for time and 20 for time, and then you're going to stop. First trick is a very basic one. If there's a pattern that repeats again and again, you don't have to keep typing. You can just have the spreadsheet do it for you. What I want you to do is click so as to highlight both of these numbers, the 0 and the 20. And that means just click inside the first cell and then drag to the second cell until they both turn blue. Good? Now you'll notice there's a little square in the lower right-hand corner of the 2 cells you selected. You're going to mouse over that till it becomes a little plus sign. You're going to click and drag down. If you don't drag far enough, how many minutes are we looking for? How many? 360. If you don't go far enough, just keep going. 340, 60. If you go too far, you'll probably have to delete, but that's easy. Any simple pattern you can do this with. Just highlight 2 cells that have that pattern, drag it, and it'll extend it as much as you want. A pretty good trick. The real trick, though, the real magic of spreadsheets, or at least the first trick you need to learn to really save yourself some time with them is what you're going to do in the second column. Go ahead and put 1 bacterium in that first cell. Just stop it a second. Now drag. So you put 1 bacterium. Here. Back down to the second one. Now, what we are going to do is a formula. Anybody learned about formulas in spreadsheets before? Oh, I'm so excited. Okay. There's really like a handful of little things you need to know in spreadsheets, and then you're set up to be able to Google anything you want to do. If you ever have a question about numbers that you're dealing with, and that question is, could spreadsheets save me time on this? The answer is always yes. I promise. Okay? Not to oversell this, but weeks of my life I've saved. Here's what we're going to do. We're going to make a formula. Any formula, every formula in Sheets or Excel. Sheets is really just Excel Lite. Starts with you telling the spreadsheet, hey, I'm about to do a formula. And the way you do that is the equal sign. Equal sign. Immediately shifts that spreadsheet. Oh, okay, he's doing math. He's going to start telling me to do some math. We're going into calculator mode. All right, do the equal sign. Now, any cell that you click on, it will decide that that cell is part of your formula. And we want the cell above to be part of that formula. So you're just going to click once on that cell that has the 1 in it. And you'll notice in that formula, B2. Well, that's because this is cell B2. It knows exactly where to look for that cell now. It's going to take whatever value is in that cell and do what you tell it to do with that value. And all you want it to do with that value is what? Multiply by 2. Now, there's another little trick, which is that, in spreadsheet language, X doesn't mean multiply. They don't use that. It's the star. Good. It's the asterisk. The one, for me, it's above the 8. Shift 8. So you want that cell times, with the asterisk, 2. That's all you got to do. And then hit enter. Don't click on anything else. Don't go elsewhere because it'll think, oh, I got to use that cell too. You hit enter, and it's done. And it just does the math for you and shows you the math. Now, if you ever want to know what that formula is, go back and click on it once, and you can see the formula up here in the function. I don't know what you call this window, function window or whatever. You can also double click on the cell and see what you typed, but then you have to hit enter again to get out of it. And you're like, big deal, I don't want to do that 20 times for every other cell. Well, here's the deal. Because you referenced the cell above, now you can just select that one, and you can drag it all the way down, and it does the math for you. Keep in mind how simple that math was and how complicated you could make it, and it would still do that. You could put a whole, like, oh my God, you could put what's the thing, the stupid formula they make you use all the time, the quadratic. No, listen to me. You could put the quadratic formula there, and it would do that with every single value. Days of your time. I'm telling you, I don't use calculators anymore. Magic. All right, sorry, you worked out. Now listen, but here, the advantage here over what you did on your calculator is that now I can select that whole range of data. Probably, I don't even know what that is. All right. Insert, and okay, last trick is just like spreadsheets don't recognize X as multiplication, they do something different. They also don't call them graphs. What do they call them? Charts. So you hit insert and chart. Why would you graph anything by hand?
That was my teacher.
Yeah, you're right. I mean, it's good practice and it's good for you. But like when you get out of school, stop graphing things by hand. Do this. When you get to college and they don't make you show your work, stop graphing things by hand. Do this. Okay, good. So once you're there, I think we're good. Just if you're ever doing like a lab report or something for another class and you need a graph, but you're not turning in a spreadsheet, these three little dots here, you just hit those, and then copy chart, and then you can paste it into a Google Doc or a Word doc or whatever you're using. Okay, so this is how you generate graphs that you can use in other stuff. Any questions? Anybody, did it not work for anybody? Anybody need help? Make sure you know how to find that sheet, because we're going to come back to it and do about 3 or 4 more graphs on it in the future.